We are going to start now lecture 4 of chapter 7, class 11th mathematics, permutations and combinations. In this lecture, we will discuss the case of permutation of the objects which are not all different. We are saying all objects now they are not different. So suppose we are saying let there be n objects and m objects are alike of one kind and the remaining n minus objects are of another kind. Then the total number of mutually distinguishable permutation that can be formed from these objects is n factorial, means total number of objects, and we have to divide this value with m factorial into n minus m factorial. Now to prove this result, we start with, suppose we have total n objects. So the total number of permutations that we can form from these n objects, suppose they are all different, then the total number of permutations we can have it is n factorial. Now out of these n objects, we have m objects of one kind and n minus of m objects of another kind. So to simplify these things, suppose I am saying that we have total 8 objects are there. The value of n we have it is 8 objects are there which are all different. We are saying they are all different. We are talking about, we have two cases, 3 objects are of one kind and remaining 5 objects they are of another kind. This is the value of m we are saying and this is the value of n minus m we are saying. Now we have to select the objects and we are saying that the number of ways to choose these objects it is say x. We are saying the number of ways to choose these objects it is x. Now in how many ways these 3 objects can be arranged? These 3 objects, or we are saying these m objects, these can be arranged in m factorial ways, or these 3 objects these can be arranged in 3 factorial ways. Similarly, when we are saying that n minus m objects are there, these can be arranged in n minus m factorial ways. We are saying we are considering them in one packet, we are considering them in another packet. In this packet, these m things can be arranged in m factorial ways. These n minus m things can be arranged in n minus m factorial ways. This will be the case if we are taking that all n objects they are different. We are considering that all n objects are different. So we are saying that these can be arranged in m factorial ways, these can be arranged in n minus m factorial ways, and the total number of permutations we are having in this case, we are supposing it is x. So what we will obtain is that x into m factorial into n minus m factorial. We are talking about m factorial is the number of ways in which we can arrange these objects, these m objects, if they are all different. N minus m factorial is number of ways in which we can arrange these n minus m objects if they are all different. And x is the number of ways in which we can arrange all these values that we have to calculate over here. That is the total number of mutually distinguishable permutations. We are saying it is x. So what this will give us? This will give us the total value as n factorial. N factorial is, look at this term over here, n factorial is all the permutation, all possible permutations that can be formed from the n objects. We want to calculate the value of x. So we are saying the value of x we have it is n factorial over m factorial into n minus m factorial, and this is our formula that we have. So this is the proof for this formula. Next is, let there be n things of which, now we are having n things of which we p1 are alike of one kind, p2 are alike of another kind, p3 are alike of another kind, and likewise p are of another kind, and the sum of all these values p1, p2, p3 it is equal to n. The total number of things we have it is n. Then the number of permutations of these n things is, we are talking about the number of permutation of these n things answer we have it is n factorial over p1 factorial, then it is p2 factorial, so on up to pr factorial. So these are the values we are saying. These are the values we are saying that these are the number of permutation of these n things. Based upon this, we have certain problems over here. First is find the number of different permutations of the letter banana. Now in this case, we are having letter B one time, then we have A, it is 3 times, then we have N, it is 2 times. Total number of letters we have it is, sum of all these it is 6. So we are saying that the number of different permutations that can be made over here, we are saying the total letters we have it is 6 factorial. B we have it is 1 letter, we are saying it is 1 factorial. A is 3 times, these are like terms we are having, so we are dividing it with 3 factorial. And N is 2 times, so we are dividing it with 2 factorial. And the answer we obtain it is 6 into 5 into 4 divided by 2. These two values gets cancelled. We are cancelling these two values, and the answer we obtain it is equal to 60. So we are saying the total number of permutations we have in this case it is 60. Next is how many words can be formed using the letter A thrice. A we are using thrice. The letter B we are using twice, and the letter C we are using it is thrice. Total number of letters we have it is, the total number of letters we have it is 8. So the answer we have it is, in this case it is 8 factorial over 3 factorial into 2 factorial into 3 factorial. We are talking about these three values. Answer we have it is 8 into 7 into 6 into 5 into 4 divided by 2 into 3 into 2. This 6 gets cancelled, this get cancelled, and on multiplying these values the answer we get it is 560. Next is find how many arrangements can be made with the letters of the word mathematics. So the total number of letters we have it is 11. Out of these we are saying that M it is occurring twice, A it is occurring twice, T it is occurring twice, and all other letters they are different. So the permutation, the total number of permutations we can form it is 11 factorial over 2 factorial into 2 factorial into 2 factorial. The answer we obtain that is equal to, on multiplying these terms, the answer you obtain it is 4989600. Now the second case we have, in how many of them are the vowels together. So the vowels in this case we have it is A, which is twice, we have E, it is once, and I it is once. So we are saying that the vowels should be together. So we are talking about the arrangement that the total letters we have it is 11, and out of these 4 should be together. So we are talking about the number of alphabets or number of positions we have now it is 8. 1 2 3, 1 2 3 4 5 6 7 and 8, because these all vowels they should be together at any one of these positions. Suppose we are saying that these vowels, these are lying at this 8th position, then the number of permutations we are talking in this case it is 8 factorial divided by, now when we are talking about these 8 alphabets, we are talking about these 8 alphabets, out of which this 8th alphabet, it is not just one alphabet, it is collection of all these alphabets. So we have again this M and T, these are twice. So we are saying in these places we will have M twice and T will be twice. So these are repeated alphabets that we have. So we have total permutations, it is 8 factorial over 2 factorial into 2 factorial. And when we are looking at these alphabets, these can themselves be arranged in 4 factorial over 2 factorial ways. So the final answer we obtain, it is for this term, the answer we have, it is 10080, and for this term the answer we have, it is 12. So the final answer we obtain in this case, it is, we are saying that number of arrangements in which 4 vowels are together, it is product of these two terms 10080 and 12, and the answer we obtain, it is 120,960. Next we have is find the number of arrangements of the letter independence. So the total number of arrangements we have over here, we are looking at this term over here. So the letters we have, it is total letters, it is total is 12, out of which we are saying N is occurring 3 times, E is occurring 4 times, D is occurring 2 times, and rest all are different. So by using the formula, the answer we have, it is 12 factorial over 3 factorial into 4 factorial into 2 factorial, and on solving this we obtain this answer. Next is, in how many of these arrangements do the words start with P? So P we are saying it is only once. So the first place we are saying the is fixed, it is P. The number of places we are left now, it is 11, and the number of terms we are left over here, we are saying 11 factorial for these terms. For the first place we are saying 1 into 11 factorial divided by, again these are repeated, it is 3 factorial, 4 factorial and 2 factorial. On solving this, the answer we obtain, it is 11 factorial divided by 3 factorial, 4 factorial, 2 factorial. The answer we get, it is 138,600. These are the number of ways. Next is, do all the vowels occur together? Next case we are talking about when all the vowels they occur together. So if we look at this word over here, we are saying it is having 5 vowels, namely the E we have, it is 4 E's, and it has 1 I, and we are saying that these should occur together. So we are considering these as treat them as single letter. And in how many ways these can be arranged? We are saying these can be arranged in 5 factorial over 4 factorial into 1 factorial way. The arrangement of these 5 letters, we are saying it can be done in this way. Now we are saying that we are considering these many letters as one letter. So how many letters are left now? It is 8 letters. Total we have 12 letters, out of which we are considering this letter, we are saying that is consisting of all the vowels, we are considering it as one letter, and the remaining letter will be, we are having 7 letters, so the total we have, it is 8 letters. So the answer we obtain in this case, it is, how many arrangements can be made? It is 8 factorial divided by, now how many of them are repeated? We have N is thrice and D is twice. These two are repeated. So we are saying it is 3 factorial into 2 factorial. And how many arrangements we already have? We are having the arrangements, it is into 5 factorial divided by 4 factorial. So the final answer we obtain, these two terms gets cancelled, we are left with is 5. And over here we are left with is 8 into 7 into 6 into 5 into 4 divided by 2 into 5, and on solving this, the answer we will obtain, it is 16800. This is the final answer that we will obtain. The third case we have is that the vowels they never occur together. So we are saying that the total number of arrangements we have, it is 163200 that we have seen, and the number of arrangements in which vowels occur together, that is equal to 16800, And when we subtract both these values, the answer we obtain, it is 164,640. This is the final answer we obtain in this third case. And the last case we are saying that the word, it starts with I and it ends with P. So the remaining letters we have, the remaining number of letters we have, it is 10 letters. And in these 10 letters we are saying there are 3N, 4E, 2D and 1C. So the number of ways we have, it is, for this I it is 1, for this P it is 1. And for these letters we are saying it is 10 factorial divided by the repeated letters we have, it is 3 factorial into 4 factorial into 2 factorial. So the total answer we, on solving these terms, on solving this term, the answer we obtain, it is 12600. So these are the number of words which we begin with I and end with P. Next is, how many different words can be formed by using the letters of the term Allahabad. So the total number of words that can be formed over here, we are saying the total letters we have, it is 9, out of which 4 A's are there, 2 L are there, 1 H, 1 B and 1 D is there. So the total number of ways we will have, it is 9 factorial divided by 4 factorial into 2 factorial, and on solving this the answer we have, it is 7560. Second is, both L's do not come together. So we are first talking about the case when L comes together. So we are saying when L comes together, we are considering that the two L we are having, we are considering them as one letter. So the remaining letters we have, now the remaining letter, or we are saying the number of letters, now number of letters to be arranged. We are talking about L, these two L we are considering them as one letter. So the remaining number of letters we are going to arrange, it is 8. And the number of arrangements that we can have, it is 8 factorial over 4 factorial. Because the A's we have, they are 4. We are having 4 A's. So we are saying that these are the number of words having both L together. That is 1680. The total number of letters we have over here, it is 7560. So we are saying the number of words with both L not occurring together, in which both L they are not occurring together, the answer we get, it is 7560 minus 1680, that is equal to 5880. So this is the answer when both L they do not come together. Last is, the vowels occupy the even positions. So the vowels we have over here, if we list these terms, we are having 4 vowels, that is we are talking about 4 A's, and we are saying that these should occupy the even positions. It should be on the second place, it is A, on fourth place it is A, on sixth place it is A, and on 8th place we are saying it is A, and these odd positions are left over here. These are the odd position, first, third, 5th and 7th we are saying these are left over here. So in how many ways these A's can be arranged? We are saying all these A's, these are fixed at these points. So the number of positions we have for this, it is 1 1 1 1. We are having these 4 positions now, and on these 4 positions we are talking about the odd positions. Now we are talking about these odd positions. We are saying the alphabets we have 2 L's, 1 H, 1 B and 1 D. We are having these alphabets are left. So the number of arrangements in which these can be kept at these places, it is 5 factorial divided by 2 factorial into 1 factorial into 1 factorial into 1 factorial in the denominator. So the answer we get it is 60. For these values we are saying that the A's they can be arranged only in one way. So the total number of ways we have it is product of these two, that is 60 into 1. So the answer we are having the number of words in which vowels occupy even place, that will be 60. In how many of the distinct permutations of letter Mississippi do the 4 I's not come together? Next we have this question. So the total number of letters we have, it is 11. We have 4 I's, we have 4 S, we have 2 P, and we have 1 M. Now we are being asked that the 4 I's they are not coming together. So the total number of ways we have, over here, it is 11 factorial over 4 factorial into 4 factorial into 2 factorial, and on solving this the answer we have it is equal to 34650. These are the total number of letters that we have. Now we are talking about the case when all I's are together. We are talking about the case when all I's are together. So we are saying that we consider the all 4 I's as one letter. We are considering it as one letter. So the remaining number of letters now we have, it is 11 minus 4 plus 1, that is equal to 8. And these 8 letters consist of 4S, 2P, 1M, and this I we are saying, this I we are talking about, it is just like a letter over. This is one letter that consists of 4 I. So the total number of permutations we have over here, it is 8 factorial divided by 4 factorial into 2 factorial, and the answer for this we have, we are saying 8 factorial over 4 factorial into 2 factorial, the answer we have it is 840. So these are the number of cases when all I's are together. Now in this question we are being asked that 4 I's they do not come together. So the answer for this case we are saying the total number of ways we have it is 34650, and in which they are not together, they are together, it is 840. So we are saying that 33810 ways are there in which the letters we are saying the words formed when I are not together. Next is how many words can be formed from the word Haryana. So the answer we will have over here, the total letters we are saying it is 7. It is 1H, 3A, 1R, 1Y and 1N. So the total number of words that can be formed, it is 7 factorial over 3 factorial, that is equal to 840. Next is how many of these have H and N together. So when we are saying that H and N are together, we are considering them as one letter, and these can be arranged in two ways. Either they can be in the form HN or they can be in the form NH. We are having two ways over here. And if we are considering this N and H as one letter, now how many letters we are left now? We are talking about, we are having 7 minus 2 plus 1 is equal to 6 letters we are talking about. So the number of ways we have it is 6 factorial over, we are having 3 A's, so it is divided with 3 factorial, and the answer in this case it is 6 factorial over 3 factorial is equal to 120. The answer we get it is 120. Now these letters they are themselves arranged in two ways. This N and H, they are arranged in two ways. So the total number of ways we will have it is 2 into 120, that is equal to 240. The next case we have is that the word begins with H and end with N. So we are saying that these two places, these are fixed. Now how many letters we are left with? It is 5 letters. We are left with is 5 letters, and out of which we are having 3A, 1 R and 1 Y. So the total number of arrangements that we can have in this case, it is 5 factorial over 3 factorial, that is equal to 20. These are the total number of arrangements that we can have. Next is we have to calculate the total number of words that can be formed having all vowels together. So we are saying the vowels we have over here, it is A and it is 3 times. The vowel we have over here, it is A and it is 3 times, and all these vowels should be together. So we are considering A as one letter. We are considering A as one letter. So what we are left with now is, we are left with the letters. It is 1 H, 1 R, 1 Y, 1 N, and one letter we have, it is A and A. So we are saying we have 1, 2, 3, 4 and 5 letters. So the permutation for these 5, all these 5 letters, these are different. So the permutations we have, it is 5p5, that is equal to 5 factorial, and the value of 5 factorial we know it is equal to 120. So we are saying that the number of words formed having all vowels together, the number of words having all vowels together, it is 120. Next is, how many ways can the letters of the word permutation can be arranged? So first case is the word starts with P and end with S. So we are saying that the word starts with P and it ends with S. So the number of terms we are left over here, it is 10 letters are left, and out of these 10 letters we are saying T occurs twice and all other are different. So the number of ways we have, it is 1 into 10 factorial by 2 factorial into 1. This P and S, these are fixed. So the value of this term will be 181440. Second is the vowels are all together. So the vowels we have over here, it is E, U, then it is A, then it is I and O. These are the vowels we have. So we are considering all these vowels as one letter. So the different letters we have now, it is we have P, we have R, M, T, T, N, S, and one letter we are talking about, it is, we are considering this as one letter. So the total number of letters now we have, it is 1, 2, 3, 4, 5, 6, 7, 8. So the answer we have, it is 8 factorial over, out of which T is repeated twice, so it is 2 factorial into the number of ways in which these letters can be arranged. All these letters, these are different. So the number of letters in which ways in which these letters can be arranged, it is 5 factorial. So on multiplying these values, the answer we obtain, it is from 8 factorial by 2 factorial we have 20160, and for 5 factorial we have, it is 120, and on multiplying both these terms 120 and 2160, the answer we get, it is 241920. So these are the number of ways that we have. Next is, if the different permutations of the word examination are listed in a dictionary, how many items are there in the list before the first word starting with E? So if we list the permutations of these words, we are having over here, it is, we are having A, the number of A we have, it is 1 and 2. Then we are having the next word. If we order them in dictionary, we will have the next word, it is alphabet, we are saying, not word. The next alphabet we will have, it is E. So if we arrange them in the dictionary, so we are saying we want to calculate the number of words, the number of permutations we can make from this term examination, which starts with A. So we are saying the first letter, it should be A, it is fixed. Now next we are left with, there are 10 letters now, we are left with over here, it is 10 letters. The total letters we have, it is 11 letters. We are saying the first place we have fixed it is, it should be A. So the remaining letters we have, it is 10 letters, and in these 10 letters we have 2 I, we have 2 N, and rest all are different. So the number of words that can be formed starting with this letter A, it will be 10 factorial over 2 factorial into 2 factorial, and the answer for this we have, it is 907200. So these are the number of words which start with A. After that, the next alphabet for the dictionary we have, it is E. So we are saying that 907200 are the words. These many words are there in the dictionary before the first word starting with E. Next is find the number of words which can be made using the letters of the word again. So when we are talking about again, the total words we have, it is, the total alphabets, it is 5. So it is 5 factorial divided by, A is repeated twice. A is repeated twice. So it is divided by 2 factorial. And on solving this, the answer we obtain, it is equal to 60. It is 5 factorial by 2 factorial is equal to 60. Next is, if these words are written as in dictionary, what will be the 50th word? So we are talking about the alphabets we have 2A. Then the next alphabet in the dictionary order that we will have, it is 1G. Then we have 1I, and then we have 1N. So the first word that can be formed, it will be AAGIN. This will be the first word in the dictionary. So we are talking, if we calculate the number of words starting with alphabet A. So the number of words starting with alphabet A, we are saying this position is fixed. Over here we are having A, G, I and N. So the number of words that can be formed, it is 4 factorial, and it comes out to be 24. So the 25th word we are saying, 25th word will start with G, and it will be G. After this we will have 2A, after that we will have I, and then we will have N. Now if we have fixed this first position G, in how many ways these can be arranged? We are having 4 alphabets, out of which 2 are same. So the answer we obtain, it is 4 factorial by 2 factorial is equal to 12. So we are saying that these 24 words are there which start with A. Then we have 12 words are there which start with G. So the total number of words up to G we will have, it is 36. Now the 37th word we are saying, if we are talking about the 37th word we will have, it will start with I, and it will be IAAGN. We want to find the 50th word. Now the total number of words that can be formed by starting with I, it will be again 4 factorial by 2 factorial, that is equal to 12. We are saying 36 plus 12, the answer we have, it is 48. So 49th word will start with N, and that word will be NAAGI. And the 50th word that we will have, it will be NAAIG. This will be the 50th word that we have to calculate. We are saying what will be the 50th word? It is NAAIG. So this thing is mentioned over here, that the 37th word we have, it is IAAGN. And the 49th word we will have, it is NAAGI, and the 50th word we have, it is NAAIG. Next question we have is, how many numbers greater than 1 million, it means we are talking, when we are saying 1 million, it means we are talking about 7-digit numbers, can be formed with the digits. It is given that the digits we have, 2 is twice, then we have 3 is thrice, 4 is one time, and 0 is one time. So the 7-digit numbers, the total, if we have to choose 7 numbers out of this, we will have the answer, it is 7 factorial by 2 factorial into 3 factorial, and the answer we get, it is equal to 420. We are saying the number of arrangements we can make from these 7 digits, it is 420. But if we are talking about 7-digit numbers, it means the first digit, it cannot be 0. So we are talking about a 7-digit number, and if we fix 0 at this point, we are saying the total, we are having 7 digits, the total arrangements with these 7 digits, it is 420. Now if we fix this 0 at this point, the number of digits we are left with, it is 6, out of which we are having 2 factorial, 2 2s and 3 3s. So the number of arrangements we can make, it is 6 factorial by 2 factorial into 3 factorial, and the answer we obtain, it is 60 ways. So we are saying that out of these 420 digits, 60 digits are there on which we will have 0 on the millionth place. We are having 60 digits for which 0 is on the millionth place. So the number of digits in which 0 is not on the millionth place, it is 420 minus 60, that is equal to 360. So we are saying the number of required numbers we have, it is 420 minus 60, that is equal to 360. Next is, how many numbers greater than 4 lakh can be formed by using the digits 0, 2, 2, 4, 4 and 5. Now what we have is, we have 0 is once, 2 is twice, 4 is twice, and 5 is one time. The total arrangements we can make from this, it is 6 factorial divided by 2 factorial into 2 factorial. These are the total arrangements I can make from these digits. Now what we require is, the number should be greater than 400,000. So we are saying we are having 1, 2, 3, 4, 5 and 6 digits. This first place, it can be filled with 4 or 5. The first case we are saying, suppose that this place is filled with 4. So what are the numbers we are left over here? What are the digits we are left over here? That will be, we have 0 once, 2 twice, 4 we have one time, and 5 we have one time. So the total number of arrangements we can make, it is 5 factorial by 2 factorial. The answer comes out to be 60. In the second case, we are saying suppose we have 5 at this place. If we have 5 at this place, now how many digits we are left with is, we have 0, it is once, 2 it is twice, and 4 it is twice. 5 is already occupied at this first place. So the arrangements that we can make in this case, it will be 5 factorial divided by 2 factorial into 2 factorial, that is equal to 30. So what we are saying over here, either we have 5 at this place or we have 4 at this place. So these are two different events we are saying, these are not occurring one after the other. So we are saying that we have to apply the addition theorem, fundamental theorem of addition. So we are saying 30 ways can be there if 4 is the first digit, and 60 ways can be there if 5 is the first digit. So the total number of the required number of ways we have, that will be given by the sum of these two, that is equal to 60 plus 30, that is equal to 90. Next is how many numbers can be formed by using the digits. It is 1, 2, 3, 4, 3, 2 and 1. So we are having 1 it is twice, 2 it is twice, 3 it is twice, and 4 it is 1 times. But we have, what condition is given over here? So that the odd digits always occupy the odd places. So if we try to enlist the places over here, we are saying we are having 1, 2, 3, 4, 5, 6 and 7 digits which are to be arranged, out of which we are saying this is the first position, second, third, fourth, fifth, sixth and 7. It is being given that the odd digits always occupy the odd places. At this 1 it is odd place, this 3 it is odd place, 5 it is odd place and 7 it is odd place. And out of these numbers we are saying we are having total odd numbers we have, it is 4. So these 4 odd numbers, these can be arranged at these places in the form, it is 4 factorial by 2 factorial into 2 factorial. The answer we obtain, it is equal to 6. Now the remaining even digits, we are saying the remaining even digits, they are to be arranged at these 3 places. So the number of arrangements that can be formed, it is 3 factorial by 2 factorial, that is equal to 3. So what we are getting from this is, we are saying the number of ways in which these odd places, the numbers can be placed in these odd places, it is 6, and the number of ways in which we can place the even numbers at the even places, that is 3. So first suppose we have placed the odd, then we are placing the even. So the total number of ways, they are given by the fundamental theorem of multiplication, and the answer we obtain, it is 6 into 3. We are saying the answer we obtain, it is given by 6 into 3 ways. So we are saying that required number of numbers we have, it is 80.